Hello everyone and welcome back to another video. Today we'll be focusing on Newton's three laws of motion and the law of universal gravitation. So, first law states that an object at rest will stay at rest and an object in motion will stay in motion unless acted upon by an unbalanced force. This is known as the law of inertia. Inertia is a property of a body that allows it to stay in motion. So a good example of this law and inertia itself would be when a car comes to a sudden stop, but the passengers in the car still move forward. This is because the passengers are moving at the same speed of the car, and the car comes to the sudden stop. The inertia of their bodies is trying to keep them in motion and so pushing them forward a bit because they don't have brakes to stop them. So basically, once an object is moving, it won't stop unless there's a force to stop it. One way you can see this is looking at objects in space. They'll always continue moving until they run into a celestial body that has enough gravity to pull them in, stop the motion. Now let's look at second law. This is called the law of acceleration, and it reads, net force of an object is directly proportional to its change in momentum. Now this firstly, let's look at net force. So when we say the net force on an object, we mean the total vector sum of all the forces. So let's say we have someone pushing on this box 4 newtons here, 5 newtons there, in those directions. Now, the net force on this box is going to be 1 newton in that direction, because the 4 here cancel out 4 over here, leaving only 1 for that direction. So that's net force. The formula to begin this law is F is equal to dmv all over dt. What this is saying is force is equal to the derivative of momentum with respect to time. Those who didn't watch my video on derivatives, I would recommend you go back and watch that one or watch any video on differentiation before looking at this. So here we have it, and then using the product rule of differentiation, we can go ahead and split this up into mass times dv dt plus v times dm dt. Now, of course, when mass is constant, which is most of the times mass of the object is constant toward motion, then dm dt is going to be 0, because as you know, if you derive a constant, you always get 0. If dm dt is 0, that means when we multiply times v, then this whole thing will be 0 here. So when this is 0, multiply times this, you're going to get back 0. And we're going to end up with f is equal to m dv dt. And as you would already know, the derivative of velocity with respect to time is acceleration. So we'd end up with f equals mass times acceleration. One thing to note is that this equation here is what is usually used to represent the formula, but it's only applicable when mass is constant. In situations where mass changes with respect to time, you're going to have to use this equation up here. Okay, let's move on. So, Newton's third law of motion states that object A exerts a force on object B, and object B will exert an equal and opposite force on object A. Let's just create two boxes here. Let's draw some arrows. Let's say this box exerts a force on this one of 5 newtons. Then, according to the law, this box will exert a force of 5 newtons back here. This force is what is known as a normal reaction force. Anytime a body exerts a force on another body, then the second body will always exert a force back in the perfect opposite direction. When you stand on the ground, you are exerting your weight on the ground, and the ground is actually exerting that same force back onto you. The simple way of saying this is that every action has an equal and opposite reaction. Now we have the law of universal gravitation. This one states that the force of attraction between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Now, in order to better understand this, let's create some circles to represent heavenly bodies. Firstly, we'll make one circle to represent the Earth and a smaller circle to represent the Moon. Then we'll approximate their centers. Now here we're saying distance between them. What it really should read is distance between their centers. So in other words, this distance here that distance is inversely proportional to the force. And so we can write a formula from the law that says G M common M over R squared is equal to F. G is a constant, universal gravitational constant, that will always be in the formula. M represents the mass of the larger object, small m represents the mass of the smaller object, and R represents the distance between their centers. So when we have R squared, we square the distance between their centers. So what this is saying is that as two objects get farther from each other, their force of attraction towards each other lessens. And if objects are larger, then they have a larger force of attraction. So every body that has mass is attracting every other body that has mass in the universe. But sometimes some bodies are so small that we don't notice it. For example, humans are so small that we don't notice our attraction to each other. The constant G is a value of 6.67 Newton meter squared per kilogram squared. We can see that here we would have meter squared when we square this, so those we cancel, and then we'd have kilogram squared with mass times mass, so those we cancel, leaving newtons for force. And that is all for this episode. See you next time.
Tell me pretty lies, look me in the face, tell me that you love me.